Hi everyone, let me give a quick start tutorial of Gephi. First, let me start up Gephi. I shall create a new project here and I shall open up the file, the graph file which we've downloaded, lesmiserables.gml, and I shall open it up. I shall select directed graph type and click on OK. So the graph has been loaded and we'll be able to see all the nodes and the edges over here. And now the few options that we have is to adjust the edge thickness over here, or center the graph with this button, then scroll the mouse to zoom in and zoom out, and click on your right mouse button and then drag it to whichever position you wanna place it to. And next we're gonna select a layout for our graph. Usually we select layouts based on force algorithms because they separate linked nodes and unlinked nodes well. So we're selecting force atlas and just click on run. In order to expand this graph a little bit, we shall increase the repulsion strength to say 10,000 and run. So this is the force atlas layout. You can see right here. And let us explore a few of the metrics. I'll go about running network diameter. Let's see. Let me keep this directed as it doesn't make any difference. And as we can see, the diameter of the graph is 5 and average path length is 2.4. The diameter is the distance between the farthest nodes in the graph. So it is said to be around 5. And let's configure the colors of the graph a little bit. So let's click on nodes, partition here, and let me choose an attribute, and let me choose the attribute to be betweenness centrality, and just click on apply. So as you can see, the betweenness centrality being listed between 0 and 2.6 and 3.25 are separated using different colors. And we can also calculate the degree. Uh, we can choose an attribute under ranking, say degree, and give a color, choose a color for it, and click on apply. So the graph has been changed according to the degree. Let us also change the size, say 20, and apply. So you can see the nodes to be a little bigger, and then let me choose the ranking to be betweenness centrality now, and give it a minimum and maximum size to be 10 and 50, and say apply. So this is what the graph looks like now and this show node labels will show the labels for each of the node, and under layout if you see here adjust by sizes, just put a tick on it and just run. Now you will be able to see the overlapping nodes will be set out right, and there won't be any kind of overlapping now. On clicking this and just running it again. Now let us detect few communities inside this network. So to detect communities we use the concept of modularity. So let me run modularity first. Randomize use weights picked up and this okay. So run modularity. Now let me go back to nodes and okay, just click on apply. So let me select modularity class over here on the partition and click on apply. So now you can see the whole graph has been differentiated or the whole graph has been formed into several clusters, and each of the cluster is being recognized by a different color over here, and the nodes which are uh, projected with a bigger size, say Valgian, Rankine, Thénardier, all these are said to be the major nodes of this graph. Also we can apply filters over this graph. If you just go to filters, topology, and you need to drag this degree range into the filter, and just if you want to see the degree between 13 and 36, just click on filter. So these are the only nodes where the degree is between 13 and 36. So you can apply your filters here to see the nodes of different degrees. Similarly, you can also compute the values of prestige uh, here, and you can also colorize it based on the prestige, proximity, and several other values related to prestige. See, so change this. So let me stick to modularity for now, and uh, form clusters in this graph. So this in turn states that all these clusters of different colors are related to each other in some way. As I haven't seen the movie Les Miserables, I won't be able to exactly point out what relation it has, but if you could Google, you'll be able to find out what kind of relationship or these the elements of this cluster would be holding with each other. So after we do whatever we need to do, we just can export the file. We go to preview, and then we just select on show labels, so it shows up all the labels, and then click on refresh. So this should be our review, and uh, and then we can click on export SVG PDF PNG button and save it as a PDF. So I'll be able to present my work in this form and derive certain conclusions out of this graph by showing different types of clusters or computing different metrics and interpreting it in different ways. So thank you all for listening to this Kickstart tutorial. See you guys later. Thank you.